Hello, and thank you for watching or attending the Rolls Battery Engineering Training Series. Today, we are going to talk about some tips and tricks when using Magnum products and Rolls flooded lead-acid batteries together. Just a note, this webinar is specifically for flooded lead-acid batteries. This is not for the valve-regulated AGM or the gel batteries. If you use the settings that I talk about in this PowerPoint for an AGM or gel, you are going to cause damage to them. My name is Steve Higgins. I'm the Technical Services Manager for Rolls Battery Company or Surratt Battery Company. Here's my contact information. My name is steve@surratt.com. My email address is steve@surratt.com. I apologize for that. If you have any questions, feel free to send me an email. I'd be more than happy to take care of you there. You can also give me a call on my mobile, just 206-790-5840. Okay. A couple of housekeeping items first. This webinar, it's a webinar. We try to keep it to about 30 to 40 minutes. It'll probably be closer to about 30 minutes at the latest. And we'll have a Q&A session at the end if there's any questions. I've muted everybody's microphone so that we don't have any issues with echo or feedback. If you don't have paying, go ahead and send me an email, and I'll be more than happy to answer your questions directly. No worries on that. Next thing is that all materials, including this webinar, sorry about that. All materials, including this webinar, are available for download. They're currently stored on a Google Drive. I'm not expecting you to write this link down. Again, if you send me an email, I will be more than happy to send you a link to the Google Drive, and I will be more than happy to also give you a list of the YouTube site. If you're watching this on YouTube, send me an email. I'll be more than happy to take care of you. So basically what we're going to talk about here today is we're going to talk about a pretty common system that we see, 16 S50s connected in series parallel. So you have two parallel string batteries, a total of 16 batteries. It gives you an 856 amp hour battery bank. We're going to talk about a 6,000 watt solar array on one PT100 solar controller. We're also going to talk about a single Magnum 4448 PAE, which has ballpark a 60 amp charger and the Magnum BMK. We're going to talk about minimum and maximum charging currents for the batteries, minimum and maximum discharge currents, estimated peak solar production during different times of the year, and of course the average charging current from the inverter specifically. So to start, minimum and maximum charging currents. Flooded lead acid batteries require a minimum of 10% of the C20 rate. And what I mean by this is that what we're looking for that minimum 10% number. Why we're looking for that is that limits the absorption time calculation. So it limits the amount of time that you're going to be charging. If you're less than 10%, for example, in a full-time home, it's not very common, especially with a solar. You're going to have 6-7 hours of sun, a full sun in a day to get a battery bank fully charged. So you got to be careful of that. On flooded lead acid batteries, your maximum is 20%. And so if for example, this particular battery bank, which is 856 amp hours, if you subject it to a greater current than 172 amps, then what'll happen is it'll actually cause positive post-lifting on the battery. That positive post-lifting basically is plate expansion. The plates get too hot. As the plates get too hot, the positive post rises out of the plate. Generally, it can be caused by temperature issues, but most often it's also a secondary cause can be overcharging. So generally for this battery bank, you're going to want between 86 and 172 amps of current minimum and maximum. If you don't have that, then what's going to happen is if you have too much, you're going to cause problems with the batteries, which would void the warranty. And that's not just Rolls batteries. It's pretty much everybody's flooded lead acid batteries. And if you don't have this current, you're going to have undercharging situations, which are going to cause problems with the batteries also. So What about minimum and maximum discharge currents? Well, typically for a renewable energy system, we are sizing these systems at a C20 discharge rate. What that means is if we have two parallel strings of S550 batteries, on one single string, the C20 discharge rate is 21 amps of current, which means you're looking at 42.8 amps of DC current. Okay, 42.8 amps of DC current. How you figure that out is you take 42.8, you multiply that by 48 volts. That gives you 2,054 watts. 2,054 watts is roughly around 1,900 to just right around 2,000 watts of AC load. Of AC load. And so you divide that by, if it's a 240 volt inverter, that means you're running 8 to 9 amps of current AC. If it's a 120 volt inverter, it's roughly 16, 17, maybe 18 amps of current, depending on the losses in the specific inverter. So if your client's running more than 42 amps of DC load, then what's happening is you're in this range, of the discharge. So actually what you're doing is you're making, let's say, for example, you're running 42 amps of AC load on two parallel strings. You're running, let's say you're running 80 amps of DC load on those two parallel strings. You'd be roughly in the 8-hour discharge rate. And so what'll happen is instead of your system lasting 10 full hours, or it goes 100% dead or 50% dead, it's going to go 50% dead in about 3.5 to 4 hours, ballpark. And so you want to be careful with that, because if your client loads a system heavier than what you've designed it for, they're going to complain about generators starting too often, batteries aren't going to be fully charged. There's a whole host of things that are going to cause issues. So what you really want to do is try to keep your clients in this range, in the C20 to the C100 hour rates. Those are the systems that the batteries are going to get to a higher state of charge for a longer period of time. They're not going to discharge as badly. So you want to try to stay with those parameters. Estimated peak solar production. I talk to many people every day, and a lot of times, just today, I talked to a customer in Puerto Rico who said he gets plenty of sunshine. He gets 10 hours of sunshine every day. Unfortunately, this isn't 100% true. In solar, generally, Puerto Rico, 6 to 8 months of the year, you're going to see 4 to 5 hours of decent sun production every day. If you're in the Pacific Northwest, you're going to see 3 or 4 months where you get 4.5 hours of sun production, but you're going to see another 7 to 8 months where you see 3, or another 6 months where you see 2 or 3, and another 2 months where you might see 1 or 2 hours of peak production. So you have to understand where your peak production is, and you have to understand that although the sun may be up, if the solar panels, if the sun isn't within a certain degree angle of the panels, you're going to lose quite a bit of your power. If you put a watt meter on a solar panel and you just angle the solar panel 30 degrees away from the sun, you're going to see your production drop almost 70–80%. You're going to go from 1,000 watts per meter squared of solar power down to 300–400 watts, and that's going to severely hamper what your solar is actually producing. So keep that in mind when you're talking about peak solar production and how much current's going into the battery. So some suggested system settings. First thing is I typically like to set up the charge controllers first, because solar is free energy. For roll-based, you must install temperature compensation. Actually, for any battery, you should be installing temperature compensation. Without temperature compensation, the inverters or the solar chargers, or any charger for that matter, is not properly charging your batteries if you don't have battery temperature compensation installed. You must have battery temperature compensation installed anywhere. If you're in Hawaii, if you're in Seattle, if you're in Halifax, if you're in Mozambique, no matter where you're at, you should always have a battery temp sensor installed, and it should be mounted to the side of the battery on the warmest battery in the battery bank. What that'll do is that'll do two things. One, battery temperature compensation adjusts the charging voltage up or down based on what the actual temperatures of the battery is. So if your batteries are at 35 degrees Celsius, you're going to see a 10-point reduction in charging voltage. So a 48-volt system, it's going to be 120 millivolts times 10. So it's going to drop your charging voltage down by 1.2 volts. And what that'll do is that'll protect your batteries to the point where you're not overcharging them. The reverse works with cold temperatures. If your client's in Yellowknife, Canada, and your batteries are, instead of being 25 degrees Celsius, they're 15 degrees Celsius, your chargers are going to raise your charging voltages to accommodate for that cold temperatures. So you must install temperature compensation. On Roll's battery product, you want to set your charging voltages on your solar chargers to 60 volts. And that's assuming at 25 degrees Celsius. Okay. And the reason for that is that, again, you're letting the solar chargers temperature compensate the charging. Okay. If you were to set that at, say, 57.6 or 58.8 or 59.6, what will happen is that you're, in effect, they'll double temp compensate. And so if the temperature's hot, your charger is going to reduce the voltage even more. You've already got a reduced voltage programmed, so the batteries are never going to see a full charge. So make sure you understand that. Make sure your customers understand that. Okay. The next thing is the absorption timer. Okay. On a PT100, your maximum limit's going to be roughly 100 amps of current with 6,000 watts of solar. Okay. Ballpark, that's about where it's going to be. Real world condition, that's going to be closer to about 80 to 90 amps. Just because you have, the panels are going to be hotter, you're going to see a reduction in voltage, and there's quite a bit lower current rating that you're going to see. So our absorption timer formula, 0.42 multiplied by the capacity of the battery bank, C20 capacity, divided by nominal current. And so on this particular system, I would set your absorption time at 3.99 hours or 4 hours. And the reason for that is that once you get to the absorption voltage, you're not 100% fully charged. You're only about 80 to 85% charged. It takes about another 4 hours for the current to get on the batteries. And what this 0.42 is the 0.42 is the assumption you're going to lose about 50 to 60% of this 90 amps. So when you get toward the end of the absorption time or middle of the absorption time, you're going to see that current drop. So another thing to take in consideration is that during certain times of the day, during certain times of the year, you are going to see a reduction in production based on the time of the year that you're operating in. So, for example, in the summer, a lot of times you see greater production. Sometimes you see less usage. So that means technically in the summertime, most people can back off how much they're charging. In the wintertime, you see more usage, you see less production, and a lot of people have larger loads. So those larger loads are going to cause problems, and so you need to raise your charging. So typically in the spring, you lower your set points, and in the fall, you raise your set points. And keep your system going smoothly and cleanly. On the PT100, one of the things about the PT100 is you can only set the charge voltage parameters if it's not plugged into the networking hub or the router, as they would call, as Magnum calls it. So if you go ahead and set your battery type to flooded and the system voltage, the absorption voltage, we've got an absorption voltage of 58.4. We've got a float voltage of 53.6 and an equalization voltage of 62 volts. And the time is defaulted at 4 hours. Be careful with this because that's not the correct voltage. So if you have a PT100 all by itself, and you say you had an Outback inverter or a Schneider inverter or an SMA inverter, and you're just using the PT100, you're not going to have, you're not going to be properly charging those batteries because your voltage is going to be low. So if you have a Magnum inverter, whatever you program the Magnum inverter to is the set point that the charge controller is going to use. So keep that in mind. A little more on the PT100, since the absorption voltages are low, you may have to, instead of absorbing for 4 hours, you might have to set your absorption time for 5, 6, 7 hours to get your batteries to a full state of charge. So one of the things you can do as an installer or as a do-it-yourself, you start these charges. You start the charges, and you check after you're done, after you're finished with the charge, and that'll help you adjust. If your specific gravity is coming low, you can raise your voltages or maybe lengthen your absorption charges. If your specific gravities are high, you can shorten your absorption times or maybe lower your voltages depending on what you got. So keep that in mind. The PT100 is a great little controller, but you kind of have to adjust it if it's all by itself. If it's got the inverter, then you should be able to adjust it specifically for our batteries. And last few years, one of the things a lot of battery companies have done have adjusted their settings higher to compensate for the lack of charge in the solar system. Typically, in the system, 4 to 6 hours is all you got, no matter where you're at. And in most cases, you've got a 800 amp hour battery bank with a 1 or 2 kilowatt solar array. And so the PV array is not really getting to a full 100% state anyways. Okay, so to the inverter. So we got the inverter. So on the inverter, what we typically would do is we would set your absorption voltage just a tad bit under your absorption voltage for charge controller. Now keep in mind, on a Magnum inverter, this is what, if you program it here, this is what the inverter and the charge controller are going to be charging at. So you may have to set both of these to 60 volts if you have both Magnum products. Then absorption timer, you have to keep taking effect all the longest absorption time. So if you have a Magnum inverter that's capable of 60 amps, we derate it by 10%, so 55 amps. So your absorption time, if it's a single inverter, is almost a little over 6.5 hours. So be careful with that. On a Magnum inverter system, you're going to have peak. You play with the system settings to get the batteries to a full state of charge on a relatively common basis. A full-time off-grid system wants to see a full 100% absorption time at least once a week. If you're doing lighter cycles, 10, 15, maybe 20% cycles every day, you might be able to deficit cycle the battery bank for a couple of weeks. But again, you want to check your specific gravities on a periodic, especially on a new system, just to make sure you're properly charging. Onto the BMK. So for flooded lead acid batteries and valve-regulated lead acid batteries, the BMK charge efficiency, the charge efficiency should be set to 80%. A brand new lead-based battery, you take out 100 amps, you have to put back 120 amps to make sure the batteries get a full state of charge. So you need to make sure that you set that properly. If you leave it defaulted, in some places it's 94, 96%. There isn't a lead battery manufacturer or a lead battery that's manufactured in the world that's greater than 80% efficient. So something to keep in mind. Amp hour capacity sizing. One of the things that the Magnum does, and Schneider also does it, is that when you set, like for example, this battery bank is an 856 amp hour battery bank. The Magnum takes that 856 amp hours and assumes 2%. So let's say it sets your end amps at 17 amps. Okay. So what happens is when the current going into the batteries drops below 17 amps of current, your BMK thinks the batteries are full. Okay. Well, that can be a problem. Because if the BMK thinks the batteries are full and they're not full, and your client sees this, or you as the owner sees this, what can happen is if you go and shut your generator off, or you assume that those batteries are 100% full because it says it's 100% full, you're getting misinformation because of an improper charging parameter. So one of the things to keep in mind is, it's exactly what I tell in some of my trainings. You teach a teenager how to do something wrong, they're going to do it the wrong way the entire life. The inverters and charge controllers are all the same way. You teach them to do them wrong, they're going to continue doing things it's going to do wrong things its entire connected its entire basically career basically. So you want to make sure that you set that up properly. So batteries are charged when current drops to less than 2% for a total of 60 minutes. 2% for 60 minutes. So typically what I'll do is I'll set my end amps at 1.5% just to be safe. And so ballpark on an 800 amp hour battery bank, I'm going to set that to about 10 to 14 amps to start. And then I'm going to adjust that based on, again, what my specific gravities come to. So again, so we'll go over this again. So if battery bank is set to 856, end amps will be 16 to 17 amps. Reduce your battery bank capacity to 600 amp hours, and that'll set your end amps at 12 amps. And so what that'll do is that'll make your end amps more reasonable, and your batteries should come to a fuller charge. And then of course your charge factor percentage, I would set that at 80%. So at this point, you're done. As an installer, you collect your check, you drive away, you're good, right? You can never check it again. You never have to check it again, right? Well, that's a big no. You always want to go back and check. You always want to give your client a call and say, hey, Joe, how is your system doing? What are your specific gravities? By following up with a client, one, it instills confidence in your client because you're checking up on them and making sure everything's good. The other thing it does is it makes sure that it allows you to back check, make sure that your settings are correct. So one of the things you do is you go, Joe, I want you to go through, this is just 12 cells. I want you to go through and measure your specific gravities of half a dozen of your cells and tell me where they're at. So if you get, 1235, 230, 225, 230, basically what that means is you're technically undercharging the battery bank. You're not properly getting those battery bank to a full state of charge, or your customer's loading it heavier than expected. So that's when you have to sit down and have a heart-to-heart with the customer, or you need to take another look at your settings. So if you're getting a little bit low settings, you might have to raise your absorption voltage. You might have to raise your float voltage. You might have to raise your absorption time. And so what you want to do with this is you want to make small adjustments. You make an adjustment, you wait a couple of weeks, you look at it again. You make an adjustment, you wait a couple of weeks, you look at it again. It's just like driving a car down the freeway. If you crank the steering wheel 90 degrees doing 70 miles an hour down the freeway, you're going to end up in the ditch, probably upside down. To stay on the road, typically what you do is you make slight adjustments. You adjust the steering of the vehicle to keep the vehicle on the road, and you're good to go. In this particular case, you take a look at gravity. You got 280, you got 1300, you got 290, 1300, 1310. What's happening here is you're basically overcharging. Now, this doesn't happen very often, but it does happen. Where you see this a lot is you see this in renewable systems that are not being used full time. For example, you've got the cabin where they come out during the weekends, or you got the hunting cabin where they're out there during the winter, or you've got the summer cabin where they're at the lake during the summer for 2, 3, 4 weeks at a time. Basically, what you want to do there is you want to kind of show that you want to educate the customer that, hey, when you're at the site and you're doing work on you're working with the system, what you want to do is you have a little bit higher voltages while you're working it, while you're cycling the battery bank, and then while you're not there, you go with lower voltage. What this does is that at the higher voltages, keep the batteries charged while you're using it. The lower voltages, gas is less, and so that way you're not having to replace water. You're not having to replace water as fast as you normally would. So something to keep in mind. So again, after a couple of weeks, you start seeing these readings. Lower your absorption voltage by 0.2, 0.4 of a volt. Lower your absorption time by 30, 45 minutes. Give it a couple weeks, see what it does, and then check your specific gravities again. By checking the specific gravities, you can guarantee you can fine tune the system and make sure that the settings are right for you. You take this system out and you install it in 100 different sites, you're going to have 60 to 70 different programming variables. Every site has a different variable, and that variable is the end user. So you've got to be conscious of that. All right, so at this point, we don't have any questions. If you have any questions, feel free to send me an email at steve@surrett.com. I will be more than happy to answer those questions for you. Again, thank you very much. If you are listening to this on YouTube, please feel free to leave me any kind of comments or any kind of questions. Any comments or questions, I will be more than happy to answer them for you. If you have any suggestions to make this better, I will be more than happy to incorporate that also. So thank you. Have a good day.